All right, everybody, welcome back to Section 2, Unit 2. Math tool overview. We're starting to get into quite a bit of layout in going through this math portion. I stopped here a second ago. I want to show you a couple things. And the reason that I'm trying to show you probably more advanced than we need to be at this point is just so that way it'll make sense of why it matters, okay? So as we're going through this and I show you a few little tricks about laying things out and how we figure stuff out, you'll understand that there's actually relevance to what I'm discussing. It's not just boring math. This is stuff we can use every day and all day. So what we were doing here is we were talking about these four equally spaced holes right here in the center. We didn't see anything that gave us a reference telling us what was on a 90-degree angle, okay? So we're going to use two squares, just two framing squares. Now this can be done with micrometers. This can be done in a lot of different fashions as well, whether it's a very precision driven measurement or if it's just a general measurement. Let's talk about it real quick. And we're going to see, what we want to do is we want to see if these angles are at a true 45. We know they're four equally spaced, so they're 90 degrees apart from each other. But if they're 10 degrees off, then that's going to make a big difference, okay? So, if we're doing this, again, my drawing's not to scale. But let's go off of this one right here. And we're going to try to line up this, and then we're going to take this framing square, and we're going to line up here at the same time. Okay, so what I'm trying to do is I'm going to try to make the center of my bolt holes line up with all 4 points. Okay, so for example here, what I want when I do this, if I'm measuring from point to point and all 4 are lining up, I'm going to look at this measurement and then at the measurement of this square as well. So right here, this is at 8 inches, this is at 8 inches, and then I also want to come over here, and if I'm here at 8 inches and 8 inches as well, then I have a perfect square. And if those points line up exactly, all 4 points, then that tells me that it's at a true 45, or that they are at 90 degrees to each other. Now, how can I tell if they're at a 45? Okay, it's hard for me to do this just standing up there, because I can't point to where I want to. So what I'm going to do is I'm going to draw in my squares as an overlay. Okay? So real quick, here, 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 and that's all I actually need is there. Okay. So what I did is I've measured, and this is 8 inches, 8 inches, 8 inches, 8 inches. So what that tells me now is that every one of these angles are 90 degrees, okay? They're square 90-degree angles. Now how can I tell? I mean, that can happen if it's 10 degrees off or if it's 30 seconds off. 30 minutes, 30 seconds, whatever. We start getting into fine precision measurement, it can be very tricky. So for example, if this was here, and we connected these ones, then they may not be to 45. They're still square. These 4 corners here are still square, but you can tell one's closer than this, it's not at a 45. So, without confusing you more, let's take away those. And let's talk about how to find out if these are at 45 degrees. This can be really simple, really easy, because we know they're 4 equally spaced, so they should be the same. They're on a diameter pattern as well, okay? So then my distance from here to here, say this is 2 inches, or sorry, we know this is 8 inches, this should be 4. This should be 4. From here to here, this should be 4. This should be 4. Basically, we're making radiuses out of the diameter of a square block. It's our centerpiece. So if this is 4 inches, and this is 4 inches, and this is 4, we know that we're perfectly square this way, and we're not off in this direction. Okay, so 4 inch here, 4 inches here means we're up and down in line here. This line is parallel to our center line. 4 inches here and 4 inches here means that these two lines are in parallel. They're also perpendicular, true 90-degree angle to this line. So now we know we are at 45 degrees. Okay? There's a lot of things that can be done with just basic geometric shapes of how we can lay things out, how we can figure things out, moving on through this system. Okay? So real quick, the next section in this book, we're going to talk about it, and then we're going to get back to a we're going to talk about the coordinate measuring system, Cartesian, whatever. And then we will get back to, but hold on, there's one more point I wanted to make here. All right, real quick. So at the same time, right, that we're figuring out a circular pattern like this, we can use that square to manipulate and make measurements throughout these different sections. If we can find one that's at 90 degrees, we can almost always find something that's 90 degrees to something else, all right? And this is where our Pythagorean theory is going to come in later, but we will always try to make a reference point out of our 2 key points. Whenever I start into a project like this, that's a whole lot of information, okay? I start in the center, and I derive everything from my 2 center lines to start with. So if you noticed on this very first one that we did, what did I do? I found my first bolt hole that started laying out in a perfect square, or on the perfect 90-degree section of my circle. I derived from there. Now I had these 4, and I can just pick one point. So if I start here, I can make a measurement here, and I usually start in this top right corner. Because we'll talk about the Cartesian numbering system here in a second. This is going to be my positive value on both sides. So I start here in this section where I don't have it. I would start my measurements there and then start working my way around. Okay? All right, so we're back to this PowerPoint. You can notice this is basically what I did a few minutes ago, is I started just adding and subtracting numbers to get my 120, 30, 60, 90, and so forth. All right? Okay, next section of this, we're going to talk about the Cartesian coordinates. 2 or 3 dimensional. It's just like graphing paper. Okay, think of graphing paper as the easiest way that I can help explain it. An origin established by using x and y, or x, y, and z values. So what we're going to be concerned with at this point, starting out, is just going to be an x and y. And then you'll understand the z values as we get along. Okay? So, just now realized that's okay. We're going to go back to that PowerPoint slide here in a minute. I'm not going to find another spot to stop. So here's our Cartesian coordinate system. Again, this is not drawn to scale by any means. There's not even straight lines, even though I got some squares there. But I drew this before I got the squares. So what I want to talk about is a positive systems. Okay, so this is what we call, these are quadrants. So my individual lines I've laid out in green, I've laid my main set out here in red, okay? So right here in dead center, this point is x 0, y is 0. This is our starting point. This section over here, quadrant 1, 2, 3, and 4, okay? So, this is 0, 0. Anything in this direction, so this is the x-axis right here, is going to be a positive. Anything in this direction is going to be a negative value. Same goes for right here. Anything in this direction is going to be a positive value. So this is our y-axis. Anything down below is going to be a negative value. Okay? Sorry. This is our y-axis going this way. X is up and down. I apologize. This depends, this is a lot of times relevant to where it is in the machine as well. You can set your base here, wherever. We'll get into that later on. Okay? But there are times when this can change. The main thing we're talking about here is we're trying to get into the positive values of this being your origin point, where we start, just like anything else. If you notice, right there's my dead center. I start everything in dead center. On this, I can start from an outside corner as well. Not going to. So, real quick, I'm going to walk through the book exercises just so that way we're keeping in line with what I'm writing in the book, or what you're seeing here in your book. You can always come back and reference it as well. So these are positive x, positive y, okay? X's are positive, y's are negative, x's are negative, y's are negative, x's are negative, y's are positive, okay? So, say these are, we're just going to start out, we're inch increments, okay? From here we go 1 inch, 2 inch, 1. So at this point, well, let me follow the book. I said I was going to. Our first one is 1 and 1. Okay? So this is an x1, y1 value. So now we're going to go over x, follow along x-axis. We're going to do x5, 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4. So this is an x5, y4. And I don't have 5 here, so we're just going to do another one. So we go over x. We're going to shoot for x3, y2. So 1, 2, 3, 1, 2. x3, y2. Okay. Next one over, let's go for an x, -2, 1, 2, +1, x, -2, y1. We're going to go for a x, -3, 1, 2, 3, y2, 1, 2. x3, y2. Now down in this value, say we're going to do an x, -1, -1. -1, -1. Y, -1. Okay? I'm sure at this point you're kind of getting the gist of it. Let's dot this value 1, 1, 2, 3. So we're at x, negative 3. 1, 2, 3. Y, negative 3. Let's pick here. 1, 2. X is a positive 2. 1, 2. We're in x or y, negative 2. Okay. So as we start laying out grid patterns, you notice how sometimes that can be the same as this. So this is a system that we use quite often in CNC machining, computer numerical controlled machining, to be able to write code and distinguish points. There are several other methods. We're not going to get into that right now. What we're mainly concerned with is that you understand, and I would make yourself familiar with x positive, y positive, x negative, y positive, both the negative values, positive x. So everything to this side is a positive x. Everything to this side is a negative y, positive y, negative x. Okay? All right. Basic trigonometry. Now this is where most people start to have a little bit of, I think you could say, a panic attack when they start hearing words like trigonometry, things like that. I'm going to read from the book here for a second. Trigonometry can be defined as math using triangles. That's all it is. Math using triangles. I want you to highlight under basic trigonometry, sum of angles. We're going to break into Pythagorean theory here in a minute. So, what we noticed here is the sum of the all angles, so we're talking about just triangles here, okay? Not circles, just triangles. The sum of all angles is 180 degrees. Okay? What does that mean? So right here we see this square block, so we know that this is 90 degrees. Okay? So that means 90 minus 180 is what? 90 degrees. So this angle and this angle must add up to equal 90 degrees. It's just a law of physics. Okay? So we know one, we need to figure out the other angles as well. I'm going to break into the sections, the breakdowns of a triangle. Okay? This is your opposite, your adjacent, your hypotenuse. These are mathematical terms. Sometimes, especially in pipe fitting, we will call this our offset. This is our run, and this is our travel. Most of the things that we are going to do in a layout pattern can be broke down into finding one right triangle. A lot of times, if we can find one right triangle, just one, within a print, then we can start drawing and doing the correct math to figure the dimensions within the entire rest of the part out. But a lot of times we need one, quite possibly two right triangles. We just need to make sure that they're right triangles, and we can work from that point on. Okay? So the Pythagorean theory, well, that was the end of it. We are going to spend some time, break down this Pythagorean theory, and try to explain why it's relevant in everything that we do. Okay? So, real quick. Pythagorean theory is a formula that relates the lengths of the sides or legs of right triangles. Not isosceles triangles, right triangles. So, if you know this, then usually you can figure a lot of stuff out. We described that a minute ago. Several companies will give you a math problem as an entrance exam for Pythagorean theory. Okay? So what is the base formula? The base formula is written as c squared is equal to a squared plus b squared. When I was doing a lot of pipe fitting, I knew this fairly well. Actually knew the values better. With just my multiplication values, you can break the theory down even more. So, let's talk about where we're going with this to start with, okay? So, A, B, and C. So how do we know what is what? So, to start with, one side is always smaller than the other, okay? In this case, it was the opposite, adjacent, hypotenuse. Now the one thing that you're going to know, that you're going to realize no matter what, okay, because these two sides can change. This side can be shorter, this one can be longer. The one thing that remains constant at all times is your hypotenuse, your C, is always your longest side, okay? So let's give you a couple mathematical equations here for it. So real quick, first example in the book tells you that A is 2.257, B is 1.430. Okay, so naturally this side is longer, this side is shorter. And what we are doing, we know these two values, so what we are trying to figure out is how long is the hypotenuse. Okay? So C is equal to the square root of a squared plus b squared. Now, why is this different than this? This is squared. So by putting the square root symbol here, it's the exact same thing as saying this. Okay? So what we're going to do is we're going to do the equation first, and then we're going to find the square root of this answer, and that will tell us what C is. Okay? So in this case, we plug in 2.257, and then 1.430 times 1.430.